Thanks for coming. I will present a case of a study about Redis. I come from the academia. I am of the Department of Computer Science of the University of Costa Rica. And she is the person that encouraged me. She is not here, but encouraged me to be here present this. First of all, I will present the agenda of this work. I will show you the background about our work, the scientific measures that we use and apply using Redis, and the advantage and future work that we have using them. So, we are a research team in NoSQL databases, and we have a highly interest to apply different technologies in atypical scenarios. We applied case studies for teaching because we are interested to teach students in the university about how they could use this kind of tools. So in that case, this specific case is the case of the study using Redis. We do interdisciplinary work with some other teams. We provide solutions to these research teams, and now we are working with geophysics and geographic research teams. For the context of this work, I live in a country that has many volcanoes. We have around 20 volcanoes, and from this quantity of volcanoes, 5 are currently active, and this represents that people live in the influence area of this volcano. Actually, 2/3 of population live around the 3 active volcanoes. So in that case, in monitoring these volcanoes is critical. So one of the problems that we have is the ash alerts, because, for example, the airport service will be shut down when the volcano make an eruption. So for this reason, and for example, the people that have breath problems, they could have a big problem when the ash alerts happens. And actually, when there is an eruptions with includes magma, people, animals, and crops and farms that is around the volcanoes will be affected. So it's really important in my country to be aware of what is happening with the volcano. This is one picture of one of the most active, the current most active volcano, that it's called Turrialba volcano. So we work with a national seismic network. They monitor volcanoes activities every single moment, because they use a lot of stations that it's located around the volcano, and they use at least 3 sensors for each station that is located in each volcano, but there are many stations around the volcano. And it represents a big amount of data, but only some portion is real-time processes, because they don't have this infrastructure to do that. And for this reason, they have valuable calculations that are not available for them. So they require a system that processes the sensor data in real time. So in that case, the scientific calculations that they know it's possible to do that. So it improves the monitoring processing and the alert to population in case of some emergency. So in that case is when we use Redis, because we consider that in-memory storage means faster processing, and we could make faster calculations, highly precise, and get update seismic measure every second or every moment. And it improves the monitoring work, because experts that monitor the volcano has more information, and the authorities has better support for early warning in case of natural hazards. And when they have on-time calculations, they could identify if there are particular events that happens in the volcanoes, and they could do future analysis just to know what is happening in these volcanoes. And actually, they could improve the algorithm efficiency using a continuous stream of data, using Redis, of course. So our solution of using Redis in that case is that all the stations that are located in the volcano has a protocol that is called SID links, and it's connected to Redis, and we process the data in Redis according to the station ID, the axis that the sensor has, and the timestamp of the data. And we store this data accordingly to calculations using hashes, lists, matrices in case of use ML model, and we are considering using streams. And each second, when we do all the calculations, we complete the calculations they needed and update these results each second and plot in that case, and this information is useful for them. One of these calculations is the real-time seismic energy measurement. Is based on an old paper, but it's currently on a stage. It is useful for them. So it's used to visualize if the seismic strain release rate is changing. So in that case, if the volcano is increasing the energy, they will understand that it will represent an eruption in the future. So the challenges that we have is that stream packages maybe not arrive in not strictly order. This is because the protocol is not exactly correct to sending packages or something related to the communication from the station and the servers. And we need to do square operations over measure every single millisecond. So in that case, Redis could help us just because we could do every calculations in the moment that we need it. So we solved this using an onto incremental hash, one hash by each station, and in each hash we have a key for each second. We could process, for example, 1 hour of data. And the possible streams could be easily identified just because we put the data or we insert the data according to the hash key. And after that, each second we applied a square root operation, and doing that, we could plot the data, and it represents important information because we could, for example, apply future analysis of future algorithms, for example, to the localization of the magma or something like that. This is the result of the previous calculations. I am not a volcanologist, but I understand because I speak with them. And the important part of this is when there are half peak of energy. So in that case, in the center of the plot, we have some more energy than the other part. There is another calculation that they do. It's called seismic spectral amplitude measurement. Also is some old, and it helps to identify if the signal that people do, the signal that comes from the volcano, it's from the volcano and not from another source. Because, for example, when there are cattle around the station, they could make a sensor movements, and these movements are not related to the volcano. And an additional challenge that we need to do a Fourier transform for a time-defined windows. And to solve that, we process the data, inserting the offline data in a Redis list. After that, we apply the Fourier transform for a time window. The time window is just for a second or something. And we could update the spectrogram each second after we complete the Fourier transform. In that case, we are considering using Redis streams. And since today I learned about Redis gears, actually Redis gears is applied in that case. The plot that we have when we complete this calculation is this spectrum. This is a spectrum that has some information about the frequency of the measurement. And for example, they could identify in the center that probably these yellow lines in the center are probably wind. But in the frequencies that is lower than 10 hertz, there are short lines that it represents some volcanic activity. So they could discard all the information about just because they notice that it's not specifically related to the volcano. Both plots are used together So in that case, the most important part is in the center, like in the where is the yellow, the biggest part of the center. And in both cases, it represents that energy is increasing, and because it's located according to the frequency that is around 10, it represents that the volcano is making, it's increasing the energy, and it comes from this source. Also, we want to complete, this is currently under development, and using the information of several stations to determine what is the specific location of the energy that comes from the volcano and the depth of this energy. In this picture, we can say that we have several seismic stations, and if we detect the energy, we could identify where is the earthquake in that case, or where is the energy related to this specific activity or event. It's based on Yorkevitz and Taisne, it's more recent papers. And in that case, we require a matrix calculation, so they are available through Redis ML model. But the current challenge that we have is we need to complete partial insertions, and they are not possible in the Redis ML model because the matrix is so large, and we need to do in a partial way. So we are trying to solve in that, and we have a high dependency on Python coding when we complete the matrix multiplication. But actually, I consider that if I will use Redis years in future, we will solve this better than with the tools that we already have. I'm going a little fast. Our advantage of using Redis is represent that in that case, the high-speed processing allow us to continuously update the plots and the immediate calculation that we have, and we could observe the evolution and the dynamics of one volcanic or each volcanic activity. This approach is better than before because the real-time calculations become really, really faster. For example, they use batch processing for specific events, but they could do that a lot of time after the event happens. So in using Redis, we could do that just in the second that it's already happening. And in that case, we consider that we could apply Redis for unconventional scenarios. We know that in most of the case, Redis are used for cache or tools that are strictly related to computer science. But in that case, it's not the case. We are trying to use Redis in a case that people, for example, the students of my university will be interested in Redis just because they could apply this kind of cases. Actually, we are under consideration some other cases such as flood alerts, and because, for example, people who lives around the rivers, I will in the next one, people who lives around rivers or influence areas could understand that maybe if the river level is increasing, they maybe need to move to another place. So in that case, they have a model that determines if the flood will be happen. So they could understand and alert the people in case of the flood, it will be happen. So for future work, we also have the need to complete the polarization model, and this is the case of to understand where is the energy located, and we want to implement two different localization algorithms and be able to compare between these algorithms and build them using the current data structure that we already have, and we are using them to plot the case that we know. So that's it. Thank you for your time, and I have a little time more, so I don't know if there is some questions. So.
Hi there. What's What sort of transaction rate do you have going through into Redis from all your...
I don't get the first one.
Sorry, what sort of transaction rate that you do come and, documents per second, that sort of thing, or keys per second?
It depends of the station, because each sensor has a rate specific for the sensor. So in the worst case, we have 100 by millisecond, but we have sensors that have better rates than this. So I think the three cases that I present, we have 100 rate for each millisecond. So it's some other question?
I have two questions, please. One question is, how do you do the prediction? You're using some machine learning algorithm, or you have some well-known algorithm to do the prediction?
Okay. In the prediction is in the case of localization. And in localization model, I will return this. In that case, it's prediction. There is two papers, for example. The Yorkevich is one paper that determines how to polarize the localization of the seismic activity, and the Seismic is the most currently, and it determines with geopositional localization where is the energy and what is the depth. But we are not producing that. We are adapting these algorithms for each volcano, because it's a general case. So we need to know that each volcano have specific characteristics. So in that case, we need to adapt all these algorithms for each volcano. And another question.
Yeah, the second question is, there's some noises in the data, right? You mentioned if there's cow went around, there's some noise data. How do you filtering out those noises from your data?
The algorithms, okay, one case was when the frequency of the data is different. The plot that is a spectrogram. In that case, we could discard a lot of information that is not useful. And the other case is when, for example, a volcano has a specific characteristic that maybe the signal of the volcano is different in that way. So they notice that this volcano is special for this thing, so they adapt the algorithm using this information for the specific volcano. Actually, the adaptations that they do for these algorithms, the both papers are in that way, just knowing that each volcano is different between them. Okay. Some other. Okay.
Thank you very
much for your time.